until we meet again. And it's pretty cold out there right now, but if you were here 15,000 years ago, it would have been a hell of a lot colder. 15,000 years, most of northern North America was covered in ice sheets 3 to 4 kilometers thick, including St. John's. This would have been covered right here. And we can see the results of that in, say, the Waterford River Valley. That's where this ice sheet went through when it was in the harbor. If you go to Western Canada, you can see modern ice sheets right now. And this is what these are, glaciers in Jasper National Park. And you can see that they move a lot of material around. They also sculpt the landscape. Imagine if these babies were 3 kilometers thick, what they would do to the landscape. What they do to the landscape in Labrador, they've left these big piles of sediment, till, huge amounts of till. And these are eskers right here. Interestingly, on the Avalon Peninsula, near the Witless Bay line, we have evidence of glaciations that are 600 million years old. So the Avalon Peninsula has been hit by these things twice, at least. Anyway, geologists, till is actually the bane of Newfoundland gardeners, but geologists are really pissed off with till, because what happens, the till covers the rocks. We like to see rocks. And then what happens is trees grow on top of the rocks, on top of the till, and we can't see them. So the till hides it. So geologists really dislike till. We can't find our rocks. So some geologists realize that if you know the ice directions, how the ice moves, and if you look at the till down ice, sometimes you can find indicator minerals in there that tell you where deposits are hidden back up ice. In fact, that's how all the diamond discoveries in northern Canada have been made. People looking at indicator minerals in till and tracing back up to where they came from. This is a traditional method of doing it. Some poor bastard has to sit there and count these grains out. He's losing his mind. And so this is the traditional method. Now we've developed a new technique at Memorial, that's what I want to talk about, using something called the MLA-SEM lab, Mineral Liberation Analyzer Scanning Electron Microscope. And what it does is we can put grains in there and it can count them, and it can tell us exactly what the minerals are, and it tells us something about their shapes and sizes, etc., etc. So this is the next slide will show sampling, maybe. Okay, here we are sampling. So what we do is we go out and collect a bucket of till. In this case, we take about 10 kilograms and put it in a salt beef bucket. You gotta love that. And we take it back to the lab, dry it, sieve it 7 different grain sizes, weigh them, and then we mount them in pucks. So we take a certain grain size that's 125 to 180 microns. We sieve them down a little bit more. We end up with 0.3 of a gram of material, out of 10 kilograms. We put it in a plastic puck like this, mount it, polish it, and put it in the MLA. And it tells us there's 20,000 particles in that sample. Now I didn't count them. Okay, the MLA did. And this is kind of product we get from the MLA. It's a map of all these grains. And here's a snapshot of one of these things, and it gives colors to the different grains. And we can actually get almost personal with the grains. So this one right here is George the Garnet. And you can see that it's made of all these different minerals. So this is what we do with this technique. Now it also has importance beyond just mineral exploration. One of the big problems with mining right now is actually hiding sulfide wastes. When they opened up the Voisey's Bay ovoid, this is the surface right here, there's actually a thin clay layer all over it, and it was not affected by oxidation. So we were trying to figure out, because again, you've heard of sandy pond and places like that where people want to put sulfide waste out in the pond. We wanted to see how nature had actually sealed off this sulfide deposit. We found that, in fact, the stuff is cemented by calcite, which is an unusual mineral. We're still trying to figure out why it worked that way. But we're also looking at how deposits break down. And again, this is Voisey's Bay right here. We're looking at how the minerals are being broken up by nature and transported away, and seeing how they break down to smaller sizes and get distributed in nature. Another exciting one I'm working on is up in northern Labrador. Canastastine, it's a meteorite impact site. This lake right here is where a meteorite hit the Earth about 30 million years ago. But what happened, the glaciers came through and destroyed the nice looking round lake. And we can't see much evidence of what the actual impactor was. So with my colleague Paul Sylvester, we're trying to figure out what it was. Was it a comet? Was it an asteroid? And we can't tell at the site, so we're looking in the till that's been transported down ice. And this is my little joke right here. We have an iron core to a metal silicate, It is at a miniature Earth. Anyway, it's a joke. It's really, it's really not. I'm off to working with Steve Bornstein, and I hope he's not here because I haven't given him data yet. But we're looking at it's located in soils around Bayverde and asbestos mine right here. We've got acicular minerals, which are wood right here. We're finding nasty things like asbestos too, so we can locate those in the environment. The other thing, we go back to the minerals. We look for minerals like zircon, these bright white ones right here. They're robust geochronometers, which means we can date them. We can take each one of these things in, shine a laser on it, get an age date. And it'll tell us the age of the till. It'll tell us the age of the rocks that the till was derived from. And what we end up with this technique is a quanta of data. We have all kinds of information on grain size, sorting, intergrowth. Our problem right now is just developing the statistical basis to interpret all the data. It's just an amazing new system. And this is probably one of my most favorite ones. It's working with Chris and Priscilla Renuff. We're trying to see if we can look at sediment from around the countryside to see if it's been disturbed anthropogenically, which might tell us that there's actually archaeological sites buried at depth underneath some of these things. So we actually just sample this material and see where did the title come from. I was in Labrador, 2011, sampling tills, came back to my house. The city of St. John's decided to put in a brand new storm sewer, dug up my whole goddamn street. I looked at this big pile of till after being in Labrador for, like I said, 2 months, and all I could say was till we meet again.